In this question, we're being given a function here, and we're being asked about what happens when you take away 12 from that function. So in the language of the SAT, they'll usually call the first one f of x and the second one g of x. We're so used to that. So let's kind of continue that trend. Let's call the new one g of x. And g of x is what you get when you take f of x and you take away 12 from it. So they told us that that function, which we call g of x, has a y-intercept at 0, -75/7. So it gives us 2 points to plug in. So the y, which is the f or g of x, is -75/7, and the x is 0. So we're plugging that in. And right now it looks like that. So now this part right here is where a lot of the confusion would lie for a lot of people. What we should do here is realize that that negative sign is like a -1. And now that we've got the -1 there, it's a little easier to see that we should be using order of operation, PEMDAS. Please excuse my dear Aunt Sally. It says that we should take care of exponents before we take care of multiplication or division. So the exponent here is the a to the 0 power, and anything to the 0 power is 1, multiplied by -1, and that entire thing is -1. So we're just going to rewrite everything. -75/7 equals -1 plus b minus 12. Combine some like terms. -75/7 is b minus 13. Add 13 to both sides. And 13 is really what number over 7? So for now, let's write it as 13/1. We can multiply by 7/7 to get a common denominator, and it's going to become 91/7. So we've got -75/7 plus 91/7 is going to give us 16/7. So we've got 16/7 equals b, and we figured out what b is. It's 16/7. The next thing the question tells us is that the product of a and b is a known number. It's 320/7. And we know what b is. So a times 16/7 is 320/7. Multiply by 7 on both sides, and we'll get a times 16 is 320. So what did we do there? We multiplied by 7 here and here. It crossed out here. It crossed out there, leaving us with 16a equals 320. Divide that by 16, and you get a equals 20, and that's our answer.